We're talking about Wi-Fi here. And a common example of channel overlapping in wireless networks would be the 2.4 GHz band used in the 802.11 networks. Keep in mind 802.11 networks use a 2.4 GHz band and 5 GHz band. So for 802.11 networks, we have the 2.401 through the 2.473 GHz frequency range, and it is used for allocating 11 channels. So within this range, we have 11 total channels, each taking up a 22 megahertz portion of the available spectrum. Setting up a wireless network to operate on a non-overlapping channel, so 1, 6, and 11 in this case, would allow multiple networks to coexist in the same area without causing interference. Is this true or is this false? Well, everything that we've said so far is factual, that the 2.4 gigahertz band is used in 802.11 networks. It's 2.4 gigahertz and 5 gigahertz. And then it operates in this 2.401 through 2.473 gigahertz frequency range, and it is allocating 11 channels. Each channel will take up 22 megahertz of our whole spectrum. So that's all true. Now, if you set up channels 1, 6, and 11 to be non-overlapping channels, this means that they're more dedicated. So if we configure our Wi-Fi network to use only one of these channels, we can minimize interference from neighborhood Wi-Fi networks or neighboring Wi-Fi networks. So things on a similar frequency, because these channels are for non-overlapping, right? They're dedicated because originally it's divided into 11 channels. Each channel is wider, and then it's assigned its frequency range, which means, yeah, the channels can overlap if we have 11 of them. And this means there's interference, and the interference could lead to slower speeds, drop connections, and other just performance issues. So our statement here is correct. If we set up a wireless network to operate on a non-overlapping channel, like 1, 6, and 11, it will allow multiple networks to coexist in the same area without interference.